Hello. Welcome to week 1 of Unleash Your Inner Game Dev. This is a lecture on basically the purpose of this course is to give students a basic understanding of the Unity fundamentals. We're going to be hitting on project design and building a final playable build. We'll be using example code and assets that I've provided in the discussion forum and in the homework notes. And today we're going to be working primarily on a remake of the arcade classic Super Breakout. My name is Jamie T. Bentley. I was formerly a visual effects artist at Method Studios, which used to be known as Mark Reed's post-production partners down in Melbourne. I've worked in over 50 commercials for Holden, Mazda, Ford, etc. and so forth. And I'm currently a senior software engineer at Playside Studios in Melbourne. Prior to that, I was the technical director at the Binary Mill. I've got over 20 games behind me, including PC and arcade games, and cumulatively all of those titles together have between 20 and 40 million downloads. Some of these have been movie tie-ins, such as SpongeBob, Sponge and the Rum, but I've also done classic arcade games like Mini Motor Racing, the App Store game Fishy Bits, which is on iOS. There's also Bouncy Bits, which is on iOS and Android. Gun Club, which is a weapon simulator, and quite a few more. I will now pass you over to Jason Howarth, who is our course director, for a few messages.
Thank you very much, Jamie, and welcome along everyone to tonight's webinar. Now, I just want to talk to you briefly tonight. My name is Jason Howarth. I am a course director at Charles Sturt University, and I want to talk to you briefly about the Master of Mobile Applications Development. Now, the subject that you're actually looking at tonight with Jamie's lecture is, in fact, based on a subject from our Master of Mobile Applications Development course offered here through Charles Sturt University. So we work very closely with IT Masters in delivering these industry programs. So we've worked with them for over a decade now. And Charles Sturt is a multi-campus regional university specialising in distance education. We are also the largest IT graduate course provider in Australia. So the course itself, the Master of Mobile Applications Development, is a 12-subject master's degree, and it really is designed for students who are wanting to perhaps move into the mobile development industry. One of the subjects you can see, I'll just try and get my little pointer. You can see down the bottom here, ITE 529 3D app development. That's actually the subject on which this short course is based. So the idea behind the Master of Mobile is that we're looking at taking students from a position where they're programming at the start C#, learning the C# language, right through to many of the technologies used in the mobile development industry today. So we're looking at cross-platform development tools such as PhoneGap, Xamarin, and Unity. So all of those different technologies are covered in the course, as well as native application development. So you can see here we have a subject ITE 530 on iOS app development. There's also one here, ITC 539 on Android app development. A number of other subjects there. I'll quickly go through some and just highlight. Cross-platform app development looks at Xamarin and PhoneGap development for, as you would expect, developing across all platforms. 3D app development is our Unity subject at Charles Sturt University. We also have mobile data architecture, ITE 508. In that subject, you're looking at designing a solution which includes a server, a back-end database, and a mobile, all working together to create this multi-tiered application. At the end of the course, all students also do this, what we call a capstone subject, ITC 571, which effectively allows you to design and build your own custom application according to what you want and according to the skills that you've learned throughout the program. In addition to those core subjects, there are 3 elective subjects that you get to choose from a pool of available subjects. So you can see there you can choose different topics ranging from one dealing with the UML and object modeling, professional programming practice which looks at debugging and designing robust programs. We've got a subject there on Java, one on application development for the Windows platform, and a few others there around marketing. And the whole idea, I guess, of the course is that it's able to take you from a position where maybe you don't know that much about programming to being able to use all of these technologies to ultimately then market your app, upload it to the App Store, and hopefully get lots of downloads, or perhaps go and work for an application development company. So just over the page now. Entry pathways to the course. There are basically three ways, or effectively two ways for you to get entry into the course. One is to have an undergraduate degree. If you do have an undergraduate degree in any discipline, you can get access to the course. You'll be admitted. The other option is if you don't have an undergraduate degree but do have relevant industry experience, then we'll certainly look at you for entry into the program through a graduate certificate pathway. Now, I'll just be speaking briefly about this tonight, but next week at the end of Jamie's presentation, I'll actually deliver a 15 or 20 minute session on this course for those who are interested, and we can talk more about those pathways. In terms of time commitment, how long does it take for you to study the degree? The 12 subject masters you can do part-time in 2 years. It's offered over 3 sessions. It equates in terms of, for each subject, requires around about 10 hours study per week. So if you're doing the standard part-time load of 2 subjects in a week, you'd be looking at around about 20 hours per week studying as a part-time student. The cost of the program briefly, for Australian and New Zealand students, you're looking at $3,000 per subject. For international students, $3,100 per subject. Textbooks costs are all included in that price. You may also be eligible for a Commonwealth Government fee help program loan, and it might be something as well you can ask your accountant to look at getting a tax rebate on for education. In terms of credit, we do offer credit for previous postgraduate study in a similar area. We can also offer credit for relevant industry certification. So if you have, for example, an industry certification dealing with Microsoft app development, we can certainly look at that for potential credit into the program. We assess credit as part of the application process. If you do want to find out whether you're eligible and indeed how much credit you might get, you can go to www.itmasters.edu.au, fill out a brief form, and we can basically pre-assess your eligibility and how much credit you would be available for to get. Now, you can also apply online at csu.edu.au/apply if you want to start in session 2. That kicks off on the 11th of July 2016, and it does cost nothing to apply. So that's pretty much all I want to talk to you about tonight. It was a really brief overview. If you do want more information about the Master of Mobile Application Development, you can contact me on the phone number there, or jhowe@csu.edu.au. Neil McCosh from IT Masters is another great person to talk to. Any questions at all, very happy to speak to you. For those of you who are interested, I can present a much more in-depth look at the course at the end of next week's lecture. For those who don't want to hear about that, you don't need to come along, and we'll do that at the conclusion of next week's lecture. We'll go into some detail around what's exactly involved in some of those subjects. So thanks very much, Jamie.
No worries, thank you. All right, so moving on. Today we're going to have an overview of the Unity workflow, and we're going to have a look at the individual parts that make up a Unity project, from scripting to third-party SDKs, art and audio, things of that nature. And basically a Unity project is built up of quite a few different elements. There's art, there's game logic, there's audio, there's user interface, and then there's metrics and monetization, which is things like ads, etc., and so forth. So art, which can be broken into quite a few different subcategories, there's all different kinds. You've got your interface art, 2D art, texture art, 3D art, and then there's the lesser known, or the sort of art that people don't think of until the game is actually finished, such as all of your marketing art, your icons, your banners, etc., and so forth. Now, dealing purely within the Unity pipeline itself, the best way to bring in 3D art is typically with the FBX file format, which is owned by Autodesk. And that being said, even Blender, which is free, it supports FBX just fine. So you're not limited to any particular tool set if you want to use your preferred package. Some people use Modo, for example, and there's even some people who use Cinema 4D. So they can all be brought in just fine. Along with that, you can also bring in character rigs for animated characters with bones, and even morph targets are now supported within Unity natively. Previously, this was something you'd need a plugin to do. So for 2D art, most of the time you'll be using Photoshop or something akin to it, perhaps GIMP or something along those lines. Now, typically 2D art, Unity supports 3D games, but there's no such thing as a 2D rendered game anymore. They're all still rendered within OpenGL, which is a 3D renderer. So all of your 2D art effectively will end up on a quad, which is two triangles put together and rendered in 3D. So once again, the best format for Unity is typically PNG. I've found that causes the least amount of issues, but it will support everything from TGA. You can also use JPEG, which I don't recommend because JPEGs are pre-compressed and then Unity will then attempt to compress them again. With image compression in Unity, it compresses to what would be known as a GPU supported format, such as DirectX or PVRTC or ETC. PVRTC is the format specifically for iPhone. ETC is actually for OpenGL, and there's also ECC2, which is pretty much the go-to format if you're using an Android device. So overall, I recommend you stick to PNG whenever possible, as it also supports alpha channels, which is quite important when you start doing game sprites, etc., because you need that transparency to work. Now, audio is typically broken up into quite a few different, discrete little areas. Obviously, interface, sound effects, music categories, and Unity's very good, and it supports a lot of formats, including old tracker formats. Now, I personally prefer to work exclusively with WAV, but because once again, Unity will compress whatever you give it, for example, music, and if you already have it compressed in MP3, you're effectively doubling up on your compression. So along with that is some other hardware issues, specifically on mobile, that you need to take into some consideration. For example, the hardware on an iPhone and an Android device only allows for a single hardware stream of MP3 to be decoded. If you use more than one MP3 at a time, you start using CPU power. It's not dedicated hardware. So the fastest way is to decode whatever format you have into RAM as something that's uncompressed, but that will mean that it takes up a lot more space. Normally for video games, the sounds are quite short. They're like blips, blops, jumping sound, maybe a little bit of, speaking. These files are actually all quite small and quite manageable. It's really only the music that you want to keep as an MP3 or it ends up as an OGG in the final version. And something you probably will never need to think about at all is 3D audio positioning. It's just done. Unity uses the Fmod as a... it uses Unity as an Fmod. Unity uses Fmod for its audio rendering. And it supports stereo, 4 channels, 5.1 channels, even 7 channels. And it just will automatically scale to whatever hardware platform you're using. So next up is game logic. Game logic is pretty much the backbone of absolutely anything you're doing. With the exception of, some of the basics, pretty much everything in game logic responds to input. That is, everything is triggered by something else. For example, you have what's called an update loop. All your characters' movement is usually handled in an update loop. The characters will move regardless of whether they're getting input, but when they get the input, they start moving. And then there's other things like mouse clicks or, touch input from a phone. That's triggering code again. So a lot of what you do will be externally sourced triggers, which is quite helpful because it makes it very easy to sort of visualize when you're writing your code. Now, typically in Unity supports Boo, C#, and JavaScript. However, they do have different compiling issues, namely that C# is compiled first, then Java, then Boo. This can cause you some problems if you try to a bit of both. JavaScript sometimes won't talk to C# and vice versa. So the way around this is just to stick the C#. It's the industry standard anyway. It's very well documented. And the JavaScript that Unity uses is so far removed now from JavaScript that they call it Unity script. Pretty much all the plugins that you get or the example code you will find, everything is in C#, so I recommend just sticking to it. Now, game logic itself can be broken into quite a few distinct categories. As the slide shows, there's player movement, which is probably the one you will spend the most time finessing, because if your character in a video game doesn't move right, the game doesn't work. So that's where you spend most of your time. Enemy behavior is fairly straightforward. World behavior, such as cars that move around in your world, or trees that move in the background, scenery, etc. Metagame behavior, that's the things like handling of scores, moving between scenes, loading screens, saving screens, things of that nature. File handling, which is some games are about creating. For example, Minecraft, you build a world and then you need to find a way to save that as a binary format. And the last one, which is very important for mobile development, is third-party integration. The examples there are, Steam, Fmod, which is a different implementation to the one built into Unity, and in-app purchasing, Google Play, ads, etc. It's not uncommon for a mobile app to have several ad providers, which are then picked at runtime for which one can fill the slot. So you will often do the majority of your project and then begin putting in SDKs for advertising and metrics, etc. So regardless of the game genre, input from the player must interact with an actor or an interface. So when you have your character running around, it has to be very responsive to the player. The moment there's that disconnect, the player will feel disconnected with the game. So you notice all the older games, specifically of the arcade sort of genre, were all very responsive. In some of the later games, they start to get this disconnect, which is it is good, but the interface will still always respond. There is still some screen cue to show that you are still interacting with the game. So after that, there's file handling, which is, as I said earlier, something like Minecraft. You need to be able to save these world states. You need to be able to load them. And along with file handling is the ability to share via network. Another thing is, for example, Pokemon sharing between Nintendo devices, or even the streaming of in-game assets. A lot of games these days will use dynamic material that they source from the internet because it's updated every day, or there's a different level each day, etc. And rather than downloading a new binary every day, we just stream the assets off the internet, which Unity allows you to do. This can also be used for text assets like language localization or even news at the start of a game. And third-party integration, which I covered on earlier. Now, there's other methods of third-party integration, not just the ones I've mentioned so far. There's also custom physics, there's tree engines, there's car physics engines, and then even distribution partners will sometimes require you to implement your SDK, or their SDK, I should say, which will allow you to chat with other users and they can put in their own metrics, etc. And this is more of the SDK stuff. So analytics we touched on earlier, but that's things like your user retention and your ad networks, etc. Networking, as I just mentioned, sometimes the Unity networking that we have now, which is now just known as Unity networking, it is quite new. Prior to this, we had Photon Bolt and Photon networking. And also scoreboards. Scoreboards are usually handled by Game Center or Google Play services. And everything that stems on from that you probably would not ordinarily code yourself, you would just code the bridge between them. And finally, game production, there is no guaranteed path from start to end. Depending on your budget, depending on your staff, you can make a game in a whole pile of ways, but regardless of how you do it, there's plenty of tips and tricks out there to find the most efficient way possible. So, at its core level, game production is based on roughly 8 different things. You've got your concepting. Typically, before you start a game, you plan it as best you can, and this is often done with a game design document. And then you have a proof of concept prototype. This is what you call a white box level. So there's not a lot in it. It's not visually appealing, but it's very playable. And it shows the game element you're going to do. For example, a platformer, you would show that the character can run, jump, and climb. And even though it doesn't look very pretty, you've proven that the game mechanic itself works. Once that works, you then branch, and you'll have your teamwork and game logic, and your artists will also just go, because art is an iterative process. And then basically you iterate through steps 4 and 5 there, and you hit on 6, and you just keep iterating until a game is exactly how you want it, or until you run out of time. And then you do your bug testing near the end. Bug testing is something that does happen throughout, but more often than not, you're feature focused earlier on in production, and right near the end you start cleaning up bugs and things of that nature. All right, so next up we're going to do a Unity overview. So if any of you have used Unity before, you'll recognize this. This is the standard Unity 5 interface running Unity 5.2.4. And first up, we'll go through the basics of navigating around a scene. So up here, we have our scene view, and then game view, and then animated view, which is something we'll cover on later. The scene view is where you get around your day-to-day. You can move into a scene, you can change views, which is what these are quite helpful for. And this square in the middle will set you to orthographic, which is no perspective to perspective. And this is where you'll spend a lot of your time, and this is what it will look like when we're playing the game. So what you'll often do is you'll break this into a separate window, which this is great if you have 2 monitors. If you don't, then it's a little more cluttered, but quite often while the game is playing, you'll still want to be able to see the scene overview. So while the game is playing on the right here, I can grab elements and move them around. So up here is where you control the game. There's play, there's pause, and then there's step, which steps through each individual frame after you've paused it. This is extremely relevant in terms of the play. You should always be very aware of the play button for one simple reason. If I make a change to the scene while the game is playing, which I can't do because they're static, let me just grab some of these. So if I move these, and I butcher the scene quite a bit, the moment I hit play, which will stop the game, everything reverts. So any changes you make to anything are reverted once you turn off play. So that means make sure it's off if you're doing proper final changes. So first up is the scene view, then the game view, which I'll just redock. I'll just close the animated tab. We don't need that. So in this view, you'll see that I have this. The hierarchy panel is every game object there is. So I've organized this. All the graphics are off at the moment because we're going to be applying those soon. The bricks I've broken. Every object in here is an object. It might not be visible, but it is an object with a transform, which we'll get into soon. So each element is an object and you can move around. So once you've selected your object over there, you have what's called the inspector panel. And the inspector panel is each individual component neatly laid out so you can see it. Every game object has a transform because they exist in 3D space, and anything that exists in 3D space needs a position, a rotation, and a scale. Every game object has a transform. It's always there. Any game object that you can see with a camera has a renderer, which is this mesh renderer. And then after that, everything is optional. We have a box collider so things can hit it. So I'll just return that to its spot. And then additional elements down here. Just get rid of that one. And then the other 2 major windows that you'll be looking at are, of course, the project view, which is down here, where we can navigate our project structure. This is also a fairly good rough layout for your standard game project. You know, you break your art, audio, resources, scripts, and shaders out. Resources is a special folder in that if you try load anything dynamically in-game, it looks for it in this folder. It's just a magical name that Unity uses. So just remember that. And also the last panel, which I keep separate, is the console. So whenever there's an error, it will come up in the console. Right now, there's no logging coming on, so because the game isn't technically doing anything, which is what we'll be looking at. But we'll see the console being used later on. All right, so the first thing we need to do with this project, which as you can see is sort of half moving, it's not quite visually there, is we're going to use all the pieces that I've just shown you to put the game together. This file is downloadable from the IT Masters website, and then you can do things along with me to get it finished. So what we'll do is the first things first. This camera, as we can see, has a white background. Now you guys haven't seen the art that I prepped for this, but actually I can probably show you. I've just popped these out of 3D Max, but effectively this is the bulk of it. It's pretty simple, and I've got a UV unwrap on it, and it will have that sort of retro glow style to it in different colors. This is not the final texture, it's just the black and white one I had, but it will do. So I've exported each one individually as an FBX object and then brought them into here and put them into my art folder, inside levels, and then there's a brick which you can see the preview here, and it comes in a scale factor of 1. A lot of 3D software has scaling issues when you export, so if you do have a scaling issue and you're too deep to sort of go re-export it properly, you can change it here and it will change it in here. I'm not going to do that because mine all exported just fine. So firstly, we're going to fix the visuals, and then we're going to start making it behave and do things. So firstly, let's fix this camera. So we're going to find the camera, which is here. Another quick tip here is if you know the name of the object you're looking for, you can just type it in this box up here. So I know I'm looking for a camera, so I can type camera, there it is. So over here, I've got the background set to a solid color, not a skybox, and I want that solid color to be black, which is going to make everything else kind of hard to see, but it's fine. So, and as you can see, when we're in scene view, if we have the camera selected, we can also see the camera preview down here. So now I'm just going to get my fence going. So this is the fence, this is Breakout, and if you've never played Breakout, it's like Pong and steroids, but for one player. There'll be a ball that bounces and breaks all these bricks, and the ball can't leave the level. And if it does, past you, when you'll be this paddle just here, it means you've lost your ball effectively. So what I've got here is a fence. Now it also has a whole pile of colliders on it, which are also renderable meshes, but they're turned off because they're just colliders. And I should point out that just because you've imported an object from 3D doesn't mean anything can touch it. That is, you need to define your collision space with primitives. So the fence itself is just that, the C-shaped fence. But without the colliders that I've added to it, which are just box objects, which have a box collider on them, nothing would be able to hit them. I'll show you how that all works in a minute. But firstly, we're going to look at the standard shader. The standard shader is great for photorealistic work. It handles radiosity, it does final gather, you can bake it. It's very robust. It isn't, however, very fast for mobile, and when you're dealing with mobile, you want to really stick to an art style that's art-heavy, processing light. So you want to do as little lighting as possible. You don't want to waste all your CPU power when you can just pre-bake it or come up with a style that works a lot cheaper. So the first thing I want to do is I'll find the fence texture they did for it, which would be this glow fence. So that's actually quite dark and you can't see it, but that's the texture there. Now, there is a default shader inside mobile. I should mention that when you're doing mobile projects, you would typically do your best to stick to the mobile shaders. They're very fast and they're quite simple for customization. You can customize them, which I'll show you in a few minutes. So this is the default additive texture. So what additive does is it means it's see-through, and it just takes the pixel beneath it and then adds the value of the texture above it. It is totally unlit. It does not require a light to get shading. And there you have this very big fence sort of thing. And I've also added a water scroller, which I wrote. So a water scroller, very simply, it just takes the texture, which is this, and then it simply offsets it every frame. And that effect, the simple script is you get this moving fence. I'm not sure what the frame rate is in this video, but there we go, it's sort of moving. So that's that. Now I'm basically going to shortcut the rest in a very efficient way. So Unity supports something very powerful called prefab. What a prefab is you'll notice everything in this menu here is blue. And if it's blue, it means it's from a prefab. So if I look in resources, you'll see that I have a couple of prefabs already existing. So if I take, which one's this? Yellow. If I take this yellow brick, well, it says it's yellow, it isn't yet, and I change its shader to the additive shaders, you'll notice that they all change. That's also because I'm working on the material. So materials are also shared between objects. If you change one material, they all change. Unless you specifically break them off into a separate material, they are all linked. So as you can see, we're starting to fill out the look a little. Now, along with that material change, there's also a texture change, which I'll put on this texture. I've also put on the wrong shader. It's meant to be mobile particles additive cold. So I should point out that that shader I just added, additive cold, is a custom shader that I wrote. It's just taken the regular mobile particle shader and turned on backface culling. Backface culling is when you turn off all of the triangles that do not face the camera. So it only renders one side of the object. Otherwise you'd be rendering both sides and you get twice the amount of fence, basically. So there's one brick done. So we repeat this process. This is an orange brick. Put the same shader on it, particles. Sorry, mobile particles, additive cold. Apply the orange texture. This one is the red brick using a red shader, a red texture. Once again, mobiles, particles, additive cold, apply the red. Do the same for the last one, which is purple. Whoops, change the shader, mobile, particles, additive cold. Alright, so we're starting to get that. And then you'll see that these two objects here, they have a spherical collider, but the actual object that I'm rendering is this flat plane, which is what I was saying earlier about sprites. If you render a 2D game, effectively it's rendering this, which is two triangles, and two triangles make a quad, which is a uniform set of triangles, effectively. So this is called the chaos ball, and the reason it's called the chaos ball is because when a ball hits it, because it's spherical, it doesn't bounce at a 45-degree angle necessarily. So this is the chaos ball texture, on it goes. So now if we hit play, everything's sort of moving. You can start to see the textures. I'm not entirely sure what frame rate you're getting there, or if you can see movement at all. But it's that's the general looks that I've been going for. Now I'm just going to add the ball, and then we'll start making the game actually do some work. So firstly, the ball is actually a cube, because I thought that would be nice and retro. Once again, it is also an additive cold, and it has a very simple texture called ball. Nothing too exciting now. And as you can see, that's also replicated into the texture as well, because that was also using the same system. Now, we have this scene, it has a look to it, and now we need to make it do something. So as I was mentioning earlier, you select your object. In this case, we've selected the paddle, which is this thing. It needs to move. So to make an object behave in Unity, it's very object-orientated, and you'll find out more about that later in the course when we start doing a bit more programming. The first thing you'll want to do is you need to add components. Now, in this particular project, I've already provided you all the scripts you'll need, and we have what's called the paddle controller. So we're going to put it on, and that's pretty much how it goes. Now, right now, I have this bound to my left and right keys, and it will just move left and right. And hopefully the video is still streaming. Yep. So I can now move this left and right as I see fit. Now, the way that was done is, obviously I've applied this. It will now only affect this object. And this was built in Visual Studio, but any code editor that you have will do just fine. And basically there's a few methods of checking for input. Now, normally if you work purely with touches for mobile device, they don't work well on PC. So what this means is you're always making two control methods regardless of platform. Because if you can't test it in the Unity editor, you can't test it efficiently. Building to device every couple of minutes becomes pretty tedious pretty quickly. So this particular one is very straightforward, and you can use this when we build to Android or iPhone or whatever your build platform of choice is. And I've actually already done the switch here. You'll notice on the component is that is mobile is not ticked. And the reason for that, which is down here, I've even added a tooltip for it, is that right here I check. If we're on iPhone or Android, I turn it on. You can turn it on manually once the game has begun, and then what this game does is if you touch the left side of the screen, the paddle goes left. If you touch the right, it will go right. It's very straightforward. And this is what the update loop effectively looks like. I've just done a, is it left, is it right here. So input mouse button, you can use these instead of, sorry, I'll zoom in a bit. You can use this instead of counting through touches, which I'll do probably in next week's, I believe it is. But for now, you can use get mouse button. Unity will automatically handle a single finger as a mouse click. So that works quite well when you're doing prototype code. And then what I've done here is very simple. I assume the direction is 0, 0 being not moving. -1 would be going left. 1 would be going right. So if the touch position, which I've said here, is on the left side of half of the screen width. So if they're touching the left side, go left. Otherwise, go right. And that effectively just moves the paddle, sorry. And it does that through this probably needlessly complex system. But at its core, the bit you're really interested there is this bit. This position here, new position.x, is the x position, which is this thing right here. Hang on, just waiting for the stream to update. In the transform panel, output position, you'll see the x, y, z. And if I change the x, the paddle will move left and right. So effectively, that's exactly what this piece of code is doing. And you'll notice that here I can refer to the transform as just transform dot. And then I can also do, transform.rotation and transform.scale, etc. Correct. All right, so that's the paddle done. There is also a script for the ball, which I will now add, because that's from here. Now you don't have to add it that way. You can actually just drag drop it onto the object if you prefer. And the bricks are already predefined, so we'll move on from there. So I'm going to grab this ball, sorry. It also has some sounds. Now the sounds are not yet applied, but I have pre-made them. And I've named them accordingly. So you would, actually I'll point out how that's done. So the ball actually took quite a little bit of code because it turns out the ball can stop moving, etc. So there's little conditions to fix that. But of the most relevance is this, where I do play sound. Very simple. It plays the sound that I send it, effectively. Now I've declared a whole pile of sounds up here. These are the audio clip class, which is just a regular class. It's an asset, effectively. And they're called bounce sound, brick sound, and launch sound. So outside of the script, if we jump back to Unity, and we have a look at the ball component, you'll see it's here. Bounce, brick, and sound. Oh, yeah, launch sound. So I'll just quickly populate those with the brick sound, the launch sound, and the bounce sound. So now that will trigger. So with just these two pre-coded little items, I can see if the game's actually going to work and hit play. So it's sort of half working. The ball is slightly invisible right now, which I'll now look into. Particles additive. That's why. Mobile particles additive. Didn't use the correct shader. So now you can see we have this sort of mustache looking face with a little ball. And as you can see, it doesn't move very quickly right now. But we can change it. So you'll notice how slow this ball is moving. While the game is still playing, I can select the ball component, and you'll see here that I have a minimum angular velocity, which is effectively how slow I will allow the ball to go. So 0.2 is clearly not very fast. If I set it to 1, it's still not all that fast. If I set it to 5, it's very fast. So that's the gist of that. So now that I know what that value is, where I'd like it to be, I'm going to bring it down to 3 actually. 5 is a bit chaotic. So if you do make a change while you're playing, like I just did, and sometimes you might set 30 or 40 different things differently in a component when you're tuning gameplay. You don't have to lose everything when you go back to non-play mode. You can copy the component by right-clicking, go and copy component, unplay, everything's been reset. I can then right-click and go paste component values. So all the changes I just made while in play mode have been kept, and I can now paste them. This is also very handy if you're doing several objects with the same components on them at the same time. For example, you can set multiple bricks up or enemies, etc. So it's very handy. So I'm going to apply that prefab, which we will cover at a later time. So now if I hit play, the ball should be going nice and fast. Whoop. Yeah. Simple stuff. So what this game also does is you can actually choose when to throw the ball. At the moment, the ball is not parented appropriately to the paddle, and that's because it's not a child, which is hierarchy, which I haven't actually mentioned yet, and I am now going to. So because everything in Unity is in a hierarchy, that means that the parent will always move the child. So you'll notice that ball that was bouncing around had a tail. That's because attached to it is this particle system. And it is a child of the ball. So wherever the ball goes, the particles follow. So now if I add the ball to the paddle just before the game starts, hopefully you can see it the stream, it follows. So this becomes a little more relevant when you start moving lots of objects around. So you notice that I've broken bricks into yellow bricks. This yellow brick is actually an object of itself. It just isn't visible, doesn't render a mesh. I can grab that and move it. And you'll notice I'm moving all of those objects individually. Or I can just grab the children individually, or just a single object at a time. So when you're doing large amounts of bulk editing, like moving trees, etc., you'll often want to group them. In more complicated games, you would have all your pathfinding nodes sort of separated, or in a racing game, your lap counters, because you'll need hundreds of them and they just clutter up your scene. And the other benefit of this which only came out in Unity 5, is that the parent object designates whether the children object is active. So if I find this brick I've got selected, the yellow one, I can turn it off very simply. And that's all the ball does. When the ball hits it, it turns it off. However, if I turn off the parent, they all turn off. Even though the object itself is still on, if its parent is off, it is off. This can be quite useful if you need to turn off hundreds of objects at a time. Yeah, so that's the basics of that done. And now what we can do is we can refine some of the gameplay elements themselves. Now, these scripts that I provided, you can use on anything. You don't have to use them in the example scene that I've given you. But another example here. So the paddle can only move so far because I've capped it. But I can extend that to -4,4, so I can move the paddle right to the edge. So there's a constant back forward between your scripts and your actual numbers. So you can see here that I have pre-coded those values of the minimum, maximum x, which is how far that paddle can move left or right. But what I really wanted to do was that as a public variable. A public variable means it's serialized, which the long and short of it means I can edit it in the inspector here, which is obviously extremely helpful when you have someone whose sole job is to make something fun to play. They need access to these numbers constantly. If, for whatever reason, you finished with gameplay modification, or you have numbers that you don't want to be editable by someone, for example, if you have an artist who isn't that good with Unity or coding, you might not want them to have that level of control, you can just remove the public. And we'll just get rid of the tooltip to go with it. So that's still there. However, you'll notice min and max x is now just max. The number's still there, but it can't be edited. Very helpful, particularly when you have larger projects and you've got 10 people working on the same project. So now that we have this relatively working game, we're going to have a very quick sort of overview of how it's been put together and what it does. So the paddle itself is just a paddle. It doesn't do anything terribly exciting. It just moves left or right, and I'll just turn on the mobile mode. This is mobile tick box, so if I click the left side of the screen, it will move left. If I click right, it will go right, etc. I can also slow that down with the speed setting that I added in the bottom right. Once again, this is all about tweaking your gameplay. I can turn mobile off so I can use my keys again. Now the ball is probably the most exciting part. And by exciting I mean there's a lot in it. Yep, so I have a look at the ball. So let's have a look at the ball and see how it works. The first thing the ball needs to do, and I probably shouldn't have called it a ball because it's a cube, the ball needs to be able to hit other objects. And it does that, shrink that down a bit, because it has a rigid body. Two colliders cannot collide unless they have a rigid body, or one of them does. So if it moves, I usually put a rigid body on it. And a rigid body is the Unity's implementation of the physics system, which is where you do the majority of your physics-based stuff, like things that have gravity, things that will collide. Anything that needs to move and interact will probably be a rigid body until you start getting very finessed, like custom car engines, etc. Those you might bypass that altogether. So in order for two objects to collide, they both need a collider. And I have a box collider on this, and I have a box collider on that, and a box collider on this. Now they're also tagged. And the reason they are tagged, which you'll see up here just above the transform section, you have tags and layers. Layers are good for rendering. So you can turn off the certain layers for cameras, etc. So it will only render parts of the scene, things of that nature. And for physics as well, physics can ignore certain layers. And then there's tags. Tags are a very quick way to identify an object when they collide. So if we have a look at the ball, I'll show what I mean. So, where are we? when the ball hits something, Unity sends a message to every component on it that derives from mono behavior. If you're not familiar with class dependencies, there is plenty of great tutorials on the Unity website itself, which I'll bring up at the end of the course, and you can be brought fully up to speed. But all you really need to know until you start doing custom classes is every new script you make will be from mono behavior. And I'll just quickly show you right now. If I make a right-click, create new C# file, just wait for the thing to catch up in the project view, and I call it test script. It adds a new object or a new component, and this is what it looks like. This is an absolute empty script. I called it test script, so Unity has pre-filled out the text and it derives mono behavior. Mono behavior will trigger the start, which happens when a game starts. There's also one just before that called awake, and every time a frame is rendered, usually it's 60 frames a second if everything's going well, it will call an update. There's also other ones like late update, and there's also early updates, etc. and so forth, but we don't need those. So just like that, where mono behavior calls those, it also calls collisions. And in this particular case, this collision is called when the ball hits something. So the long and short of it is, this line here is your standard way of handling all collisions in Unity, basically. And you can actually copy paste that directly from the Unity manual itself. And then from here on, it's all custom. But the tag that I mentioned earlier, contact other collider tag, brick. Now, the relevance of this is this collision has quite a lot of information in it. It'll have everything from what object it hit, the speed it hit it, etc. and so forth. And inside that is a contact point, which is another class. And the contact point holds the angle you hit at, the position you hit at, the collider that you hit it with, and the collider that you hit. And from that information, I can then derive useful information, like I know the other collider. So if the ball, which is this object here, hits this object, which will just fit. So imagine the ball, the two colliders collide here. This also has a box collider. I need to identify what have I hit. Now, you'll notice that each individual object has a different name. So checking against a single name it's impossible, or at least slow. Checking for a part of a name is also extremely slow, because strings are the slowest possible thing you can work with, unless they're enumerable, which these are. So this tag is brick, and you can just add additional tags with the add tag. So we can also add test tag, etc., which we'll use in a second. And then we'll select the brick again. So it's set as a brick. Now, when I hit, I check against the other collider and the tag that was on it. If it's a brick, we remove the brick, which is just here. This is where I turn it off. We also play a sound, and we also log that. That's for special effects, which is particles coming off it, etc. It's not terribly relevant. So now this game doesn't throw any errors, but if it was to throw an error, it would come up in the console. So I'm just adding a debug.log, which will come up in the console, and when it triggers, we'll know that this piece of code has been executed. So we're going to do this with a debug.log. We hit a brick called contact, other collider, .game object, .name. And I can spell too. So that's been added when we hit the brick, and we'll just have a look at how that works, because we haven't so far. Open the console. Should probably reset that back to where it belongs. Okay, there we go. It's back where it belongs. So we hit play, and once it hits a yellow brick, you'll see we hit a brick called brick yellow 5, brick yellow 6, 6, 6, etc. So the benefit of that little aside from knowing roughly where your code is, if you double click it, ignore that, if you double click it, it will tell you, it will just take you directly to where it is. So this is super relevant when it comes to things like errors. For example, if I do, let's say for the sake of interest, I want to force an error. I want to make the ball just bind to something that doesn't exist. Transform.parent equals GameObject.find something that doesn't exist. If all goes well, that should log an error. Whoops, and it will need to be the transform of the GameObject, which we'll go into in coding examples a bit later. So playing, should hit a brick. All right, you'll notice it has logged an error, a null reference exception, which a null reference is probably the most common error you're going to get. And it's taken me directly to the error, so now I know that my error is somewhere in here, and it's quite descriptive. Object reference was not set to an instance of an object. The reference, of course, is the transform.parent, or is trying to return a game object that does not exist. So it's coming back as a null reference. And that is pretty much the basics of how you find bugs. Proper or more in-depth debugging can be done with specialized tools, such as Visual Studio. You can step through code line by line, but we will be touching that in a couple of weeks. For now, we have a working project, and the last thing we need to do is to build it. So now that the game actually works, I'll just double check that that is the case, make sure I haven't broken it. Bounce, bounce, bounce. Yep, all working. Okay, so what we're going to do, we want to build this to our mobile phones or to our PCs or to our Mac or even to web. We need to go into the File, Build Settings tab. Inside Build Settings, at the moment you can see I have it in PC, Mac, Linux and Standalone, or Linux Standalone, sorry. It's the easiest one for testing. It's not terribly relevant for phones, but I'm just going to do this one very quickly. So I'm going to put that on my desktop in a new folder called Test. I'm going to call it Test Build. It will build relatively quickly. It's not a very big scene, so it shouldn't take too long. All right, so that popped up a window on my other monitor, and it's produced Test Build. This is a portable executable. You can send this to anyone with a Windows PC, and it will work and play. So when you run it, it will ask what resolution you'd like to play it in. Let's just do something in a window for now. When we hit play, the game will work just like a regular PC game. You can also do it full screen, etc. and so forth. Just waiting for the web stream to catch up there. There we go. All right, so next one we want to build for Android. We can build to iOS, we can build to, well, obviously Unity supports pretty much everything now. In fact, they just announced support for the Nintendo 3DS as well, so that's fairly interesting news. So we're going to switch platform to Android. When you do a platform switch, all of your textures are recompressed to the optimal format for that system. For Android, that's ETC, or ETC2 if you're targeting newer devices, but it's neither here nor there. So the moment we switch platform, it will now convert the project. That was fast. Okay. On some projects where you might have 2 or 3 gig of assets, that can take an hour or two. This little project with 3 textures in it, not so bad. So now that we've done that, we need to have a look at the player settings. This is an additional tab that you will need to pay a lot of attention to. When you're building for Android or iOS, the settings in here basically will determine whether or not it will work on a phone. So the first thing about this game is I don't want it to be portrait, because if we have a look at it in the portrait ratio, which you can do in the aspect ratio setting of the editor or the game view, you'll see that the game is not terribly well formatted for portrait, so I'm going to force it to landscape. And that basically means you have to use the phone on its side. So I untick all the portrait support. Now, you would put in your icons here if you had some. I haven't prepared an icon for this, but I can drag in the ball texture as the default icon. And now they'll all be that cube looking thing. Don't need an Android banner. Splash image, you'll need a Pro Unity license to turn that on, but effectively that's when Unity loads on a mobile device, it shows a splash screen while it loads in all of the engine behind it. And on to the most important part, the other settings. It's called other settings, but it's very important. So when you name something, everything in both iOS and Windows Phone and Android is com.company name, so my company, .app name. So this would be test game, I guess. Versions, bundle codes, which we'll touch on at a later date. And then you need to select your minimum API level. Now, you guys, if you've installed the Android SDK, you've probably downloaded the latest, but you'll need to drop back to, I recommend 4.4 onwards, preferably 4.4, because not everyone in the world has moved to, Android 5 Lollipop higher yet. So I'm going to select 4.4, and I know I have that API installed. Configuration, we'll soon be using that, but for now we're using mono. And then lastly, the most important is this, what you sign it with. In Android, it allows you to build to any device without actually testing it or having it signed, and you don't need a developer account to do it. But for iOS, that's not the case. So it's a little bit harder to get building straight to iPhone. And also this pipeline here is identical regardless of Windows or Mac. You can build a iOS project out of this, but you still need to build it onto the device through Xcode on a Mac, which is quite important. Android you can build on either, iOS not so much. So up here you'll see all the different build settings. This is for web player, download, which is the one we just did. Then there's iPhone settings, you'll notice has a couple more. But once again, it's all fairly similar to the Android system. So if you don't have your store key yet, which you download, or you generate one, which we'll do in a minute, you can just do an unsigned build. So with all that set, and I should test game. Up here is the name that will appear on the device. And it's just going to be test game because I lack originality. And now I hit build, and it's going to provide me with an APK. So, yeah, I'll put it there. So it's going to call it test. And it will now build an APK that I can then copy and install to the phone. If my phone was plugged in, which it isn't, but if it was, it would also build it to the phone. It would automatically handle the copying. If the copying fails, you still have the APK. So sometimes you might unplug it, it might go flat, you might get a phone call in the middle of it and the phone freaks out. Either way, it will still produce you the APK, which you can then install manually with ADB, which is something we'll touch on at a later date because it involves the terminal and consoles. So that right there, if you had a phone plugged in, would build to your phone, and then you'd be playing it on your phone. So it's relatively straightforward to get from Unity to a device. Obviously through iPhone you have to deal with all your mobile provisioning, which means you need an App Store developer account, and they can take anywhere from 3 days to 3 months to get, depending on whether you're a single person or a business. So that is something to look forward to. And that wraps up the building part, and now it's time for questions, which I will just get. One second. Okay, so the first question I've got here is how do you download Unity and Visual Studio? Well, the good news is that the internet has you covered. You can download Unity from unity3d.com, which I'll just quickly load now. And you can literally just go get Unity 5. and you can just hit the free download unless you're willing to sign up immediately. But I recommend waiting until you have a product that's nearly ready to go, because a lot of these pro features you won't need until the very end. So you hit the free download, and then you can download the installer for OS X or Windows. They're planning on a Linux editor, but it doesn't exist just yet. At the moment, you can only make games for Linux. You can't make games with Linux, if that makes any sense. It now also comes with, I think, Visual Studio Community as well, and it will automatically install that when you download it. So,
Sorry, can you hear me, Jamie?
yes, I can hear you.
Yep. So I've got a bunch of questions here as well that I can read out to you. Are you ready for them, or?
Yes, far away.
Yep. So I'll just go in the order that I have them down. Firstly, can you utilize the raw files of programs like Blender instead of using the FBX format?
That's a valid question. I haven't actually tried using the Blender pipeline myself. I'm a 3D Studio Max Maya XSI user. I would recommend using the FBX format for the simple reason the raw files, and I presume they mean scene files or project files, they're going to have a lot of additional stuff in them that you just don't need. Unless there's Blender raw format, unless there's more to that format that I'm presently aware of, the raw mesh. Let me just check. Uni 3D Blender raw mesh. Apparently you can import .raw, which I was not aware of. So yes, in theory you can use that.
Awesome. So another question is more specifically about your experiences. Did you build SpongeBob on the run based on business requirements? And if so, how long did it take for it to go into production? And what was the budget?
Well, total turnaround time on that was approximately 6 months. The company I was working for, they pitched it as a runner, and we were fairly well known for making good runners. So we had a lot of the experience required. Unfortunately, I can't mention the budget, but yeah, you can get a rough ballpark by the fact that it took us approximately 6 months with a team of around 8 to 10 people.
Yep. Question for people who haven't used Unity before, I guess. How good of a laptop or PC do they need to run Unity and any other programs that you will be providing in this course?
Well, to be honest, if you're doing mobile development, it's not so much the power of the PC. If it can render anything in 3D, like even your onboard Intel chipset is probably going to get the job done. If you can play any game on it at all, it's probably good enough to make a game with. The only thing I would say is that if you use Unity on a smaller window or a smaller monitor, it gets crowded very quickly. And this becomes an issue when you start doing interface design and things of that nature.
That makes sense. So what kind of things would you load dynamically? Would you load prefabs into variables?
That's a valid question, actually. So most things you can probably preload. On a mobile, it's best to preload everything that you can, but sometimes you just can't. For example, if you have, just trying to think for a moment, something you load dynamically. For example, another player jumps into a multiplayer game. You might have 100 characters in your game. You don't preload 100 characters because you might only support 8 players. So when that player comes in, you'll need to load that resource, which you do with, you can either do it with resources.load, which is not asynchronous, or you could use, resources.load async, which is an asynchronous load. And then you would load that data dynamically. You can also do that for things like downloading files from the internet. That's effectively resources.load call from a www source. Scoreboards, just data that you might not have on hand. For example, if you have a level that never ends, but you need to stream that data in somewhere, so that's a resources load.
Sorry, I just muted myself because of my keyboard's ridiculously loud. So you've mentioned a couple of tools earlier for 3D art and music. Will they be available to download?
Blender is available anywhere. You can just,
Mhm.
I think it's just blender.com, but yeah, blender.org for Blender. So that can be downloaded anywhere, and that will be the bulk of your 3D art. And yeah, you can just download it straight off the front page. As for sound is kind of, it can be quite complicated, but the easiest one to use straight off the bat is Audacity. And that's just for editing sounds, because just because you find a sound you might like from either a collection of sounds or you found it on the internet or you've recorded something, it might have a lot of extra stuff you don't need. It might be a minute long, but you need 1 second of it. So Audacity will get the cutting of that just nice and quick and efficient. As for art, GIMP is the free version, but if you can get Photoshop or anything like it, I highly recommend it. Now, as for music itself, there's a whole pile of free music software. I'm not familiar with that much of it, but I'm sure a quick Googling will get you sorted. I can compile a list if you'd like, and we'll put it up in the notes.
That would be quite handy, actually.
Okay, I'll do that
Thank
for
you
you.
very much for that. So when you wrote the shader, did you do it in C# or did you copy an I can't tell if it's exiting or exciting shader, and can you do it in a graphical interface?
Right. So if you're from Unreal, you'll be very sad that Unity does not yet have the same shader sort of environment. That shader was based on the default shader. So I've literally just taken the one they had and then changed it. So by default, Unity uses what's called Shader Lab. It's its own little format, but it's effectively just an OpenGL sort of shader language. And all I did was here, typically it says cull off. And it doesn't look very pretty, so I just removed it. This is a fairly simple shader, obviously, because it's for mobile, but if you want visual shader editing, like you would have in Unreal, the plugin that Unity recommends is called Shader Forge, and it's effectively the exact same thing as the one from Unreal, but it's been sort of ported to work. And you can get that from Shader Forge, this website, which I can also link. It is, however, about $80, so it's not free. And there might be some free knockoffs of it. I'm not sure, but you should definitely have a look at the asset store and find out. But this will allow you let's just load this image, your node-based shader editing. I will say that there is a slight downside to node-based editing, and that is it's often less efficient in terms of rendering power because it will do everything in full floating point where you might not need it, things of that nature. But you can still produce a shader and then go in and optimize it afterwards. I'll just leave that there if anyone might be interested.
Are students supposed to know all the Visual Basic programming to be able to understand this course?
No, because I provided nearly all the code you'll need. Also, we're not using, did you say Visual Basic or Visual Studio?
Visual Basic.
Yeah, so we're using C#, which isn't quite the same as Visual Basic, but any programming experience is a plus. You won't technically need it, but you're obviously in for a slightly tougher job if you have no programming experience. But I will be heavily documenting everything in the code. So if I do throw you into code, you should be able to figure it out.
Mm-hmm. So Jamie, we do have a fairly long list of questions. Just let me know when you need me to stop. Otherwise, I'll keep going. Would that suit you?
Yeah, just keep going. It's all good.
Yep. Someone has Kwaja just asked, as they're a recent science graduate with the yearning to branch off into game development, they're curious to know how you would describe your experience working in the industry. Are there any highlights or moments that were exceptionally rewarding?
That's a very long answer, but I'm sure I can abbreviate it somewhat. I I was quite fortunate in that because I came from a technical background in visual production or visual effects, effectively as a 3D artist, um, I sidestepped the junior programming thing. I was already a partial owner of the company I was working at, and the recession hit, and we went, hey, what can we do to make money? Oh, let's make games. How hard can it be? The answer is quite hard. That being said, if you can produce a quality product, someone will buy it. So, but in terms of whether it's rewarding, that depends purely on how much of the project is your own. For example, if you're doing something relatively trivial on a large project, it can be very hard to find that fulfilling unless it's, for example, SpongeBob. If you were just someone working on the shadow technology of SpongeBob, what you would feel good about is, hey, I worked on a SpongeBob game. But if it's more your own design, your own style, then every time you get over a breakthrough, like you build an epic way to control a car, or you get networking to work for the first time, it's extremely rewarding. And it's one of those jobs where you might work until 2 or 3 a.m. without noticing that you've lost track of time.
Yep. So I've lost track of my question. Sorry about that. Is there any benefit to turning off objects instead of destroying them?
Yes. Yes, there is. A very, very important one, which will come up later in the optimization part of this course, and that is specifically pooling. Pooling is when you need an object again. For example, every time you destroy an object, you create garbage, like it has a memory overhead. It used to exist, and now that memory hole needs to be filled. So if you have, for example, a rapid-firing weapon or a rocket or something of that nature, to create 10 new objects every second, let's say it fires at 10 shots a second, to create a new one 10 times a second and then delete them is very wasteful, and you'll start using, because you can't just clear that memory immediately. RAM takes time to clear. So when you clear that RAM, you'll get a stuttering gameplay. So you want as little allocation and deallocation going on as possible during gameplay. So the way around this is if you can only fire 10 rounds a second and the maximum age of a missile, for example, is only going to be 5 seconds, well, you immediately know you only need 50 rockets. And that's more than they'll ever need. So you're better off having 50 rockets that exist all at once, and then as rocket 1 is used, it gets turned off. You iterate through the pool until, there's a free rocket, let's use that free rocket that we had. There's no memory overhead for doing that. There's no dynamic loading. There's no dynamic destruction of the object. So you just reuse it. And this happens with enemies, sounds especially, projectiles, debris, particles. Always try to reuse everywhere.
Sorry. A quick question about the homework for this week.
Yes.
Would you be able to just briefly go what exactly you want the students to be doing?
Yes. So what I'd like them to do is to download this example project. I can also upload the completed version of it where I've made all of these changes, etc., and it's all working. And then what I'd like them to do is familiarize themselves with the interface and change this game to be more interesting. Just for example, if I take this object here, or I can just take the ball. I have the ball. Now I have 3 of them. Now, this is the laziest of possible examples, but you'll see there's now 3 balls all bouncing around at once, and it's absolute chaos. So with the scripts that I provided, plus, you don't have to stick to this same level. You can be a little creative. You can use just your primitive objects that you can add any way you want, really. You can even use spheres, etc. You can use different shading, different lighting. Just take what I've provided here and make something new. With what I provided and a little bit of extra work, you could possibly make Space Invaders, for example, or you could easily make Pong. Just take this and build something new with it. and then make sure it's fun to play, and then post it into the forums. I'd love to see it.
Yep. Thanks for that.
Oh,
And
actually, one more thing would be to build it to a device.
yeah.
If you have an Android phone, or a little bit more difficultly a Windows phone, it'd be great if you could get it to a device, because it's amazing when you finally see your game on a phone.
James suggests that you take a selfie with it as well.
Why not?
Okay. Maybe. What were so Richard would like to know what the Ninja Star type things in the interface were.
Oh yeah, the gizmos. So these little Ninja Star things. That means there's a particle system there. It means particles. I don't know why that's their icon, but each individual ball. Let me just get rid of the two other balls. The other ball here, you can see underneath it in the hierarchy panel, there's a particle system. And that's just the generic icon, or the gizmo, for that. So I've selected the ball, and because its child is one of those, I could see it. And now I can't for some reason. I appear to have turned gizmos off. Anyway, it was a particle system is the short answer.
Yep. So let's make this the last question, as we're a fair bit over time.
Sure.
Is it industry standard to use C# instead of Unity script?
Yes, definitely industry standard.
Yep. And yeah, that's pretty much it. Another quick question. Well, someone has just asked about the homework. You can add the whole project, or you can. I assume they can just build for one of the platforms. They don't need to build for them all, Jamie?
Yeah, that's correct.
Yep. And also, in regards to C# being the industry standard, why is that the case?
Because Unity was originally built for OS X. Specifically, it's a Mac engine originally, but it was built with a .NET background. It was built with Mono. So because of that, the entire scripting backend is compiled with .NET. It's also a very old version of it, but that is why.
Awesome. Thank you very much for answering all the questions.
No worries. All right, well, I think that concludes it for today. Hope you guys had fun, and I will see you at the next lecture.
If anyone has any further questions, please feel free to post them on the forums, and we'll get to them ASAP. Have a good evening all.